Alrighty, hello. We're on 9.1 talking about square roots. And in just a second, I'm going to draw a little picture for you guys that will involve a square and will involve roots so that you can understand this. Now, when I say square roots, what comes to mind? And actually today I have my class in here with me during this live recording. So someone raise your hand. What comes to mind when I say square roots? Yes, you in the hoodie.
Like square trees.
Square trees. Okay, because I just said roots and squares. All right, thank you. Let me tell you what I want to come to your mind. If you would like to draw this in your notes, go right ahead. But if you've got a tree here, all right, and here's the ground. Trees have roots, no duh. Now, some of these roots kind of grow sideways. Some of them grow in all directions, but obviously there are roots that grow down and some grow sideways, making what type of shape? Pretend like there is a square here, okay? So we've got roots coming down, we've got roots going sideways, and pretend there's a square. Now, squares, the lengths of each side are the same, which we represent like this, right? So if this root growing straight down was 9, you would know that this one growing straight to the side, that side length was 9, right? Now if I asked you, what is the area? What is the area of this square? You would know to do 9 times 9, right? Now 9 times 9, someone in this class want to raise your hand? Mariah?
81.
81. Thank you. So here's what a square root is. 9 times 9 equals 81. We can write that as 9 squared because there's 2 9s, so we put an exponent of 2 equals 81. Now, square root is just the opposite of squaring something. So what is these, oops, not 31. What is the square root of 81? If it's the opposite of squaring something, the square root of 81, you nodding your head, what would you say square root of 81 is? Uh-oh, someone's not paying. Who wants to raise their hand? Oh, it's 9. As you look at this video here, you'll see that 9 times 9 equals 81, or 9 squared equals 81. So the square root of 81 is whatever number times itself gives you 81. So let's try another one here before we go on. What is the square root? Raise your hand, someone in this class. What's the square root of 36? Grant.
6.
6. Exactly, because 6 squared equals 36. Now watch this. Those of you that are moving on to algebra soon. If I had a problem like this, y squared equals 100, and I told you to solve that using algebra, you would think, I need to get y by itself, and I need to do something to both sides to get rid of that square. The opposite of squaring something is to take the square root. So, watch this. Square root, y squared, equals, I'm just going to do the square root to both sides. This square root symbol gets rid of that exponent 2. So those are now gone. So we've got y equals the square root of 100. What is the square root of 100? What times itself? Someone raise your hand. What times itself gives you 100? Kendra? 10. Y equals 10. Okay. So let's see what your book has to say here about this. The numbers 5 and -5 are the square roots of 25 because 5 squared equals 25 and -5 squared equals 25. Wait just a second. -5 squared equals 25. Is that true? Yes, that is true. Now class, viewers, I want you to notice a very important difference here. Right here I have -5 in the parentheses squared. from a short commercial break. Okay, so negative 5 squared. If you have the parentheses here, that means negative 5 times negative 5. Someone in this class, every time negative 5 times negative, or a negative number times a negative number is always going to be what?
Positive.
Positive, thank you. All right, so is it possible then, and here's what separates those of you who think you know about square roots from those of you who actually do know about square roots. If I asked you straight up, hey, what's the square root of 25? And you told me, oh, it's a number times itself, it's 5. Well, if you leave out negative 5, you're wrong. You have to have negative 5 and 5. But let me show you one more thing that might be tricky. If I've got negative and then 5 squared like this, or this can also be written like, here, I'll show you this. It can also be written like this, negative 5 squared. The parentheses in these examples look different than the parentheses here. These parentheses say, hey, it's negative 5 times another negative 5. This parentheses, this isn't a negative 5 squared, it's actually a 5 squared first. Why is that? Because of order of operations. Please excuse my dear Aunt Sally. Please being parentheses. Excuse being what? Exponents. So you would have to do the exponent first. 5 squared is 25, and then you've got this negative out front, so this one actually is negative 25. This one here is negative 25. So make sure that your parentheses look like this. Okay, let's move on from that. Basically, they're telling you here a radical expression is anything with a radical sign. I know you probably haven't heard the word radical before with math, but radical signs are these square root signs. In the future, you'll learn that you don't have to just take a square root of something. You can take a cubed root of something, or a fourth root of something. So like 27, just for fun. Check this out. 27 is the same as what number times itself 3 times? Anybody think of that? 9 times 9 times 9 give you 27? 3. 3 times 3 times 3. So the cubed root of 27 equals 3. But anyway, you don't need to know that right now. All right, so positive, negative. Let me flip the page. We got to move on. Oh, I never finished my square analogy with the roots here. If you've got a square, and this is why it's called a square root, because if you do one side of a square times the other side of a square, you're going to get some number, in this case 81, that is always a multiple of 2 of its sides, and the sides are always the same. So check this out. If I had a square and I told you that the area was 45 meters squared, okay? And I asked you, hey, what is the length of this side? And what is the length of this side? You know they're going to be the same, right? Basically, you're trying to find, what number times itself gives me 45? Well, that one is not a perfect square. It's not a whole number answer, is it? You'd have to get out your calculator, which I'll do right now, which my class is doing right now. Find my square root button. Square root of 45 is 6.708203932. What that means is if I do times, so on my calculator, if you guys can look at the screen here, answer times, so my answer is this, times, I'm just going to type that in again, 6.708203932. Enter. I should get 45 or very close to it. Here we go. 45. All right? So that's why it's called a square root, because it works with the shape of a square. All right, next thing to learn, and then we'll be on to a word problem and we'll be done. You can approximate a square root even without a calculator. So check this out. You can use a number line to approximate the square root of 95. Oh, where'd it go? I'm sorry, let me get this down here. There we go. You can use a number line to approximate the square root of 95 to the nearest whole number. So think about this for a second. Square root of 95. 95 will not give you a perfect square, which, what is this perfect square, by the way? It's any number that has integer square roots. So, like, what is a square root of 1? Someone raise your hand here. What's square root of 1? What times itself gives you 1? Kendra? 1. Yeah. So 1 times 1 gives you 1. Square root of 4 is, just say it out loud. No, the square roots of 4 is 2. 2 times 2. Is 2 a whole number, yes or no? Yes, it is. Square root of 9 is 3. Square root of 16 is 4. And so on and so forth. These are called perfect squares. Okay. 95, though. Can you think in your head right now of a number times itself that gives you 95? A whole number?
No.
No. So 95 is not a perfect square. So how can we figure out what the closest whole number is? Here's what you do. Put on a number line the square root of 95. Do you think the square root of, well, is 100 a perfect square? 100 is a perfect square. Do you think the square root of 100 will be to the right of the square root of 95 or the left? It's the square root of a bigger number, so it's going to be to the right. Square root of 100. And then what's the number to the left, the next perfect square lower than 95?
90.
90? Can you think of a number that times itself gives you 90? 10 times 10 is 100. What's 9 times 9? 81. So square root of 81. So we know that the square, we already figured something out here. We're trying to figure out what the square root of 95 is. We already figured out that it's somewhere in between 9 and 10. It's somewhere in that range. So do you think, but we have to figure out, let's see, this problem says to the nearest whole number. So we have to choose, is the square root of 95 closer to 9 or is it closer to 10? Well, what number, and I'm asking the class here, I'm asking you that's watching this, what number is halfway in between 9 and 10? 9.5, right? So let's go ahead and do 9.5 squared and see what that ends up as. So 9.5, and I have a square button. Enter. 90.25. See that? So the square root, let's see, 90.25. So the square root of 90.25 is going to be directly in the middle here. 90.25 gives us 9.5. Now our number that we're doing, 95, is it bigger than 90.25 or is it smaller? It's bigger, okay? So the square root of 95 is going to be bigger than 9.5, making it closer to 10 or closer to 9? Closer to 10. All right, so our answer would be 10. Okay, that's what they did here. 9.5, 9, 10 is the square root of 100. Square root of 95 is somewhere in there, so we know it's closest to 10. Hope that makes sense. If not, you can rewatch that part. Let's do one word problem, and then we'll be on our way. So check this out. On an amusement park ride, riders stand against, oh, this is an awesome ride. I wonder if any of you have ever done this. I have, once. Riders stand against a circular wall that spins. At a certain speed, the floor drops out and the force of the rotation keeps the riders pinned against the wall. The model S equals 4.95 times the square root, by the way, this means times between these, 4.95 times the square root of R, gives the speed needed to keep the riders pinned to the wall. In the model, S is the speed in meters per second, and R is the radius of the ride in meters. So depending on how big this ride is, I mean, if you have a ride where the radius is that big, and a ride where the radius is that big, these two circles could spin at different speeds to keep the riders pinned against the wall. The radius does matter. Okay? Find the speed necessary to keep riders pinned to the wall of a ride that has a radius of 2.61 meters. All right. So radius, 2.61 meters. All you got to do is use this formula, 4.95 times the square root of, and don't we know what r is? It's 2.61. So, just solve that out now. Square root 2.61, enter. And then I'm going to do times 4.95. My answer times that, 7.9969. I'm going to round that up to 8. So my speed is 8, and what was it measured in? Meters per second. 8 meters per second is the speed it would take. And let's see if I got it. That's pretty close. Looks like they didn't do the rounding. Actually, they got a different answer. Oh, they rounded. Okay, so square root of 2.61. Can you see my calculator here? Gives you 1.6155, and look what they did here. They just rounded that number off. So whose answer is more correct, mine or the book's? Everyone's like, yours? They rounded before their final answer. I didn't. So my answer was actually a little more precise than theirs. But anyway, so that's how you work with that. As you begin your assignment today, and you do some of these easy problems like, what times itself gives you 64? Oh, I know that's 8. Here's how you can write positive and negative 8 all at once. You put plus or minus. That's how we say that. Plus or minus 8. Make sure to put that. Unless you're dealing with a word problem. In this word problem, if I put plus or minus 1.62, okay, you guys following me here? If I put plus or minus 1.62, let's say negative 1.62 times 4.95, you can't do a speed of negative 8. All right, it doesn't work. So if you're dealing with just math stuff, put plus or minus. But if you're dealing with shapes or word problems, use the positive. All right, that's it for square roots. I hope you got your mind wrapped around it. We'll see you next time.